It is an honor to be graced by the presence of such an accomplished editor, author, and referee and professor, Sir Dr. and Professor Syed Jafari sir is an accomplished individual in the field of general topology. Thank you, sir, for accepting our invitation, for giving the speech today, and guiding our students to new beginnings. Sir did his PhD in Graz University of Technology, Graz, Austria, and master degree in Albert University in Denmark, and also Sir passed in theoretical and practical parts of the teacher and university teacher training in mathematics and philosophy. It is a postgraduate teacher training, and Sir is also a referee of over 55 various international and national journals. And Sir is also an associate editor of the Journal of Egyptian Mathematical Sciences. It is an elsewhere.com journal. Under his guidance, 30 students have got their doctoral degree, and Sir has currently doing many research projects also. Also, he attended and presented different papers in various conferences, seminars, and workshops. With this short introduction, once again, I welcome you, sir. We are very honored to have you here, sir. Now, the session is yours, sir.
Thank you, ma'am. Let me enthusiastically invite our esteemed speaker, Professor S. Jafari, Professor, College of Vestsjaelland, Sir, Mathematical and Physical Science Foundation, Slavos, Denmark, to deliver the presentation. Over to you, sir.
Thank you very much. I thank you, the organizer of this conference, and especially Dr. Khan, who invited me to give this lecture. So this is the first lecture I'm giving at 7:30 in the morning from Denmark time. So my talk is about on some values and certain Hilbert algebras based on fuzzy points. I hope that the audience are interested in it. It was a short time actually to prepare it, and it should be polished. So that's why I promised to give this talk. Okay, no problem. Then I proceed with this. I hope you can see it. Yes? Can you see this?
Yes, sir.
Okay, thanks a lot. As you mentioned, that I'm from Mathematical and Physical Science Foundation, also College of Vestsjaelland South in Denmark, and my talk concerns some values and sets in Hilbert algebras based on fuzzy points. We know that there are two definitions about the fuzzy points, one from Lowen and one from Zade, and of course there are other definitions, but we will see to it when I go through this this talk. Let me see. This is a joint work which is not finished. As I mentioned, we should polish it and so on with Dr. M. Rayesh and the Professor Nordo. In my talk, focus on introduction of a new class of generalized fuzzy subalgebras and present some of their basic properties. Moreover, I characterize them by applying their level sets, subsets, and I offer the new notion of epsilon epsilon VQ primable S value and for the fuzzy sets, and provide some related features. By defining notion of primable S value for a fuzzy set, which here we use O line, my colleague and I were able to establish some basic properties. As we know, the algebraic structures play a prominent role in mathematics with wide-ranging application in many disciplines, such as theoretical physics, computer science, control engineering, and you name it, lots of different, it is influencing in all branches of science, actually. It has been, actually, yes. This provides sufficient motivation for researchers to review various concepts and results from the realm of abstract algebra in the broad framework of fuzzy setting. the concept of Hilbert algebra was introduced by Diego, which I think the paper is in French. It is sur l'algèbre cohomologie, and he used it actually for Hilbert algebra for first time in 1966. He proved that Hilbert algebra formed a variety which is locally finite, and Hilbert algebra was treated by D. Wozniak and June, and some of their filters forming deductive system were recognized by Dudek. Considered the falsification of solid algebra and deductive system in Hilbert algebras. There is a deep relation between Hilbert algebras and posetsets. Today, Hilbert algebras have been studied by many authors, and they have been applied to many branches of mathematics, such as group functional analysis, probability theory, topology, fuzzy set theory, and so on. Also, we made actually a paper concerning nitrosophic sets and topology and algebra. Various problems in system identification involve characteristics which are essentially non-probabilistic in nature. In response to these situations, others introduced the fuzzy set theory, as we know, and alternative to probability theory. Uncertainty is an attribute of information. In order to suggest a more general framework, the approach to uncertainty is outlined by Zadeh. Well, in this paper, this talk, we introduced new generalized fuzzy subalgebras and study some of their basic properties. Actually, we have written a paper which will be published in Korea in AFM concerning Hilbert subalgebras, and it will be published. It is in the section, the paper in press. So we characterize these generalized subalgebras by their level subsets. Some characterization of the generalized fuzzy subalgebras are also established. In addition, the notions of primable S value for a fuzzy set and its definition are introduced, and some related properties are investigated. So if you take, for example, a Hilbert algebra, those who are familiar with this, then we have the operation star and 1 on an algebra which we call X, then the following 4 conditions and also the other one, the 5, are satisfied. So as you can see, if you take 3 elements from belonging to Hilbert algebras and using this operation star, and you can see at the first one, when it's applied, it gives 0, and the second one, for every X, when it's applied on 0 to X member is X, and from the left, of course, 0 from the left and 0 from the right, it is 0. And if you take, if we see that X, it is commutative, X star Y is equal to 0 and Y star X is equal to 0, then this implies that X is the same as Y. So we define a binary relation, which is less than or equal on a Hilbert algebra as follows. We take every X and Y belonging to H when X is less than or equal to Y, if and only if X star Y is equal to 0. And in a Hilbert algebra, the following assertions are valid. So I just show them. It is a long list, actually. So as you can see, these conditions should be valid. Then we have in a Hilbert algebra. So we have the definition. A non-empty subset of a Hilbert algebra whole star 1 is called a Hilbert subalgebra of H if for all X and Y belonging to H and X belonging to S and Y belonging to S, X star Y is belonging to S. So the third definition of what is set mu is in a Hilbert algebra, H is said to be a fuzzy ideal of H if the following conditions are fulfilled. It should be held, not hold. Okay, it should be, I think it should be held, yes. So you can say mu of 1 is greater than or equal to mu X, and mu X star Y is greater than or equal to mu Y. it is also true that which we use the third one actually a lot. So mu of y star under y star x again is greater or equal to minimum of mu of y1 and mu of y2 for all x, y1 and y2 belonging to H. And we have some properties concerning the fuzzy subalgebra of Hilbert algebra, as you can see, epsilon, we call it, and VQ. So in what follows, H denotes a Hilbert algebra. And fuzzy set mu in H is called a fuzzy algebra. From now on, I don't mention epsilon, VQ to make it easier to talk about this, okay? So I call it just fuzzy subalgebra of H if it satisfies the following condition. So this condition should be fulfilled if we want to have a fuzzy subalgebra. So the definition 3.2, a fuzzy set mu in H is called a fuzzy subalgebra of H if the following condition. It is the same actually. This is a mistake. This is the same definition. Okay, sorry for that. Oh, example 3.3, let H be 1, A, B, and C, D with following Kelly table and mu be a fuzzy set defined as it's seen below. Then H is a Hilbert algebra, as we can see. Then we ascribe these grades, 0, 7, 8, 0, 6, 0, 4, and 0, 4. And then mu is a fuzzy subalgebra of H. Another example to see that we have which H is a Hilbert algebra by ascribing actually defining mu as you can see it. So if we ascribe M is 0, 2, where we have VQ, we have the level set which is equal to H if T belonging to this interval, as you can see it. And it is 1 ACD if T is belong to 0, 4 and 0, 4, 5, and the singleton B if T is belonging to 0, 4, 5 and 0, 4, 9. All of them is open from the left and closed from the right. So since the singleton B is not a subalgebra of H, so the level set is not a subalgebra of T belonging to this interval, as you can see, it's 0, 4, 5 and 0, 4. Yes?
So can you move the slide? It's not moving. No, sir. For us, no, the slide is not moving. Can you move the slide, sir?
I cannot understand what are you. Can you tell me what is wrong?
So can you move the slide, PowerPoint slides?
You cannot see the slides?
Yes, sir. So we want the first slide.
You cannot see the slides?
No.
Oh
No,
my
sir.
God. Sorry for that. Okay. This is
Thank you, sir.
let me see. Sorry for that. Okay, why this happens?
So now the slide is moving. Yeah, we
Yes.
can see.
Yes. Yes. Okay, let me. Can you see it now?
Yes, sir.
Okay. Can you see that I go through the slides? Can you see it?
Yes, sir.
Okay. So it is okay that I continue? Can you see it now? Can I continue?
Yes,
okay,
yes,
thank
sir.
you very much. Maybe it is because of the net, I don't know. Sometimes eruptions happens, Okay. So we have this theorem, a fuzzy set mu in H is an epsilon Q fuzzy subalgebra of H if and only if mu x star y is greater than and equal to minimum of mu x, mu y, and degree of 0.5 holds for all x and y belonging to H. And this is the proof. I don't go through all this proof, but it is based on those conditions I mentioned earlier, definitions, you know, should be used, and reductive ad absurdum. You know, you start from something which is not, against what is the fact in the theorem, and then you get a contradiction. Okay, so the proof is here, and those who are interested, I can send it to them. You know what I mean? So this is a long truth, though, so I don't go through it. The same is true with this one, which we have a fuzzy set mu of H. We say that it is an epsilon VQ fuzzy subalgebra of H if and only if each non-empty level set where T is belonging to the 0 and 0.5 interval, open from the left and closed from the right, is a subalgebra of H. You know, so we can assume, for example, that mu is a fuzzy subalgebra of H, and then we take this T, which stands in the theorem as it is, and we take also x and y belonging to level set, and we say that, okay, in this case, so mu of x is greater than equal to T, and the same is true with y. Then follows that the star product of them fulfill that condition, you know, which holds for all x and y belonging to H, and that and also the star product, which is greater than of minimum of mu x, mu y, and 0.5, it will be also greater than and equal to minimum of T and 0.5, which is equal to T. Okay, so then we get to the point that x star y is belonging to the level set. And then we say that the level set is an epsilon VQ fuzzy subalgebra of H. Then we go and prove the converse situation, and we start with reductive ad absurdum, and we get a contradiction, and we prove that it is actually the level set, you know, is a subalgebra of H. I hope you can see the slides, so I can continue. There are lots of pages, so I cannot go through all the theorems, you know. So yes, you can see the, yes, you can see the slides, yes. I hope you can see the slides.
No, sir.
You cannot see the slides?
No, the slide is not moving. So.
Oh my God!
It's still
Why?
at the page.
Why? I don't understand. Okay, let me just. It is. I don't know why it is. What is wrong with that? It is really.
Yeah, the slide is on 15th slide.
Yes, my internet, you know, it is fine. There is nothing wrong with that. So I don't know what is the reason that this behaves like that, you know. It is a little bit strange to me.
The slide in if it's free.
What about now? It is good? You can see it?
No, now it's moving, but when you're reaching, it's not moving.
Oh, yeah. It's moving, but you cannot. No. Let me see. Let me just close it and again and see if it is better. You know, it is. This is the first time. Actually, it functions very nicely, and so I show it now. Can you see it now?
Yes, sir.
Okay. I move it? Can you see the movement?
The slide at 15.
Can you see the movement of it?
No, sir.
Oh.
No, it's stuck at 15 slide.
Yes, I don't know why it is so. Because it is. What about now? Can you? Is it moving now? What is now?
No, sir, it's not moving.
Oh yeah, I don't know what is the reason because my net is very fine. You know, there is a. I don't know what is so what is the problem. You know, because I have done it before and there is no problem. So by
Can you put it in a full screen?
Okay.
And you have the option in under the slide show.
Let me do it again. So, I move it now, and can you see it is moving?
Yeah, it's moving. So,
It is moving now. Oh my God.
yeah.
Okay.
Can
Okay.
you
This.
go to the next page, sir?
Okay. Can you see this? It is moving. Okay.
No, sir.
This is.
Can you share it to our professors, sir? Can you share this PPT to our professors? Or can we present?
Can I send it to Dr. Cannon or what?
Mailing.
And he could do it for me. Then I can read from that or what? Is it that you mean?
Sir, you can share it to the convention.
I don't know why this is so very strange.
To the WhatsApp to our email.
Okay, I send it to Professor Cannon. Okay.
Okay, sir. Okay.
Oh my God. Okay, I have sent it via email.
Yes, sir.
So I think everything is okay now. I don't know what is the reason actually.
So could you wait for a few minutes, sir?
Okay, no problem. Okay, it's okay.
Thank you, sir. Thank you.
I cannot hear you because there are so many microphones are open. You know, that's why. You know, it's intermingling with each other. That's why I cannot hear you.
So you're visible?
Yes, I can hear you now. Okay.
See the slide, in the slide.
Okay. So I am on page 18. Yes.
Okay.
Okay. Then you managed to change the pages. Okay. As I mentioned, there are lots of proofs, and in this short time, I cannot go through all of them. As I mentioned, what results we have obtained, and we finish the talk because now this is this complication. I'm sorry for that. And if we take a non-empty subset M of H, which is a Hilbert algebra, is a subalgebra of H and only if its characteristic function is a fuzzy subalgebra. I don't know. There are lots of in the background. I don't know which as if some people are talking or doing something. You know what I mean? No problem. So let's go to page 19. Page 19. Then we have theorem 310, which for every subalgebra M of H and every T belonging to this interval from 0 to 0.5, there exists a fuzzy subalgebra of mu of H, which the level set is equal to M. So the proof also is there, which is based on where we get a contradiction and we prove it that it is true. And again, as you can, yes? Yes? Is it okay?
Yes, sir.
Let's go to the page 20. The intersection of any family of fuzzy subalgebra of H is an epsilon G fuzzy subalgebra of H. Okay. Let's go to the page 21. But 21 again is based on this proof, as you can see it, which we use the condition that mu is mu of x star y is a supermum of mu I, which I is belonging to delta of x star y. And you can see it that this, based on theorem 5, as I mentioned before, mu is a fuzzy subalgebra of H. Okay? And this, go to page 22. As you can see, there is an example which we show that the union of two fuzzy subalgebra of H is not necessarily a fuzzy subalgebra of in general. Okay, and we use the Kelly table with this, which we define two fuzzy sets, mu and nu, and this showing that this is not true, as you can see it from the page 23. Page 23. Okay, as you can see, we have examples. Those interested, I can send the paper, no problem, later on. And let's go to the page 25.
25.
25, yes. As you can see, that the union of ordered family of fuzzy subalgebras of H is a fuzzy subalgebra of H. You can see this is also, again, proof is based on infimum, not supermum, and minimum. And you can prove it easily. This is not a problem. And this is also the proof on page 26. Let's go to page 27. As you can see that in this case, M is 0.5. And if you take any finite strictly increasing chain of subalgebras, then there exists a fuzzy subalgebra mu of H, whose level subalgebra are precisely the members of the chain, as you can see. So we have the proof, you know. Let's go to the page 28. as you can see that for any fuzzy set mu in H and T belonging to the unit interval given from the left, we define two sets. As you can see it, the bracket of mu with respect to T is defined in this manner, and you can see that the level set of Q, and also as you can see, the definition of the bracket mu is equal to union of these two level sets. Let's go to page 29. Again, there is a situation that we use this bracket of mu, and it showed that we call this as a level subalgebra of mu, in the case that we have an epsilon mu q, you know what I mean? So this is the proof, okay? So I think this go away from all of this, and let me see. I have lots of results actually. Okay, let's go to page 34. Page 30. Okay, we have a homomorphism from two. We have two Hilbert algebras. If mu is an epsilon VQ fuzzy solid algebra of Y, the inverse of mu is a fuzzy solid algebra of H. And the proof is very easy, as you can see it. So let's see. And let's go to the page 35, which we have an important definition. Between two Hilbert spaces, we have a function. Then we say that mu VQ fuzzy subalgebra of mu is said to be F invariant if f of x is equal to f of y, which implies mu x is equal to mu y for all x and y belonging to the Hilbert space H1. And on page 36, as you can see, that we have also a situation which we can define actually f of mu as you can see it, in the slide. Because if mu is f invariant, then f of mu is also a fuzzy subalgebra of H2. So let's go to the page 38. Let's go to the page 38. This is concerning permeable values, which actually we have two level sets here. We have defined, we call them strong and upper lower T level sets. And we have a definition concerning a subset of a Hilbert space, which is set as energetic if it satisfies this condition, It is very important, actually, if we take, for example, the intersection of two singleton here, not two singleton, it is a set, of A or B, which both of them equal to Hilbert spaces, which shouldn't be empty. Then we have many results concerning this. As you can see in page 39, it happens that when you have these level sets, then you can see that the level set, if you take the condition that T belonging to the interval close from 0 to 0.5, then the level set is, if it is different from empty set, then it is S energetic subset of H. H is a Hilbert algebra. So let's go to, I think, let's go to the page 43. Because I omit all these proofs because we don't have time for it, and the talk is technical. So if we take, for example, this example, you can see that the Kelly table, as you can see it, with a Hilbert algebra, which is 0a b1, which is defined in the following manner. then if we take, for example, t belonging to the open interval of 0.55 and 0.59, then we can see that the level set is equal to the set 0 and a, which is empty, and u star of mu and t is equal to b1, which is a subalgebra of a. This is a good example, I think. When we have a definition on page 44, let's take mu to be a fuzzy set in H and t belonging to the unit interval. Okay, with u star mu of t, which is not empty. Okay, then t is called a primable S value for mu if the following assertion is valid. It means that for every a and b belonging to Hilbert algebra, and mu of a star b greater than and equal to t, maximum of the set mu of a and mu of b is greater than or equal to t. Okay, so this is our definition. Okay, then I have an example for it as follows. Again, we use the Kelly table and give an example for that. Let's see, let's go to the page 47. Please tell they should close the microphones because I can hear some voices. I don't know. Okay, let me be a fuzzy set in H. Then every primable S value for mu is an epsilon VQ primable S value for mu. And you can see there is an example which you can use it because this is an Hilbert algebra with the binary operation. And we have defined it in the manner which mu is 1, A, B, and C. And they have their ascribing 0.5, 0.4, and 0.6, and 0.3. And you can see that if t belonging to the open interval 0.3 and 0.4, then we can see that we have primable S value for mu, but it is not a primable S value for mu since mu C star C is equal to mu of 1 equal to 0.1, which is greater than or equal to t. Okay, as you can see it, this is also a good example. Then we have this theorem on page 48, which I don't go through it, concerning when a level set is an S energetic subset of the Hilbert algebra H. So if we have, for example, again a mu, which is a fuzzy subalgebra of H, if t belonging to the 0.51 interval and open from the right, and with u star different from empty set, then we can see that it is an primable S value for mu. Then we can see the level set u is an S energetic subset of H, and it is the proof. Proof is very easy. Okay, I don't go through all of this because of the time. So let me see. Let's go on page 51. Let's say at mu be a fuzzy set in H. Then if we take an element t belonging to the interval 0.51, which is open from the right, with a level set which is different from empty set, then the following are fulfilled. You know, they are equivalent actually. If t is an epsilon VQ primable S value for mu, and the level set is an S energetic subset of H, it means that whenever you have the first one, then you get the second, and vice versa. Okay, the proof is there based on definitions and some of the lemmas and theorems. Okay. Let's go to, let me see, I choose a page. Again, this is very technical now. On page 50, we go to all line epsilon and V of Q, which is a subalgebra with the same condition. Then we can see that if we take every two elements of Hilbert algebra, the maximum of the mu x star y ascribing 0.5 is greater than equal to minimum of the set mu x mu y, and the proof is there, as you can see. I think I go to page 55 now. Let mu be a fuzzy set in H, and if we have a level set which is different from empty set for all t belonging to the interval 0.5 and 1, open from the right, and if mu is the overlying fuzzy subalgebra of H, then the strong upper T level of set of mu is either empty or a subalgebra of H. And you can see the proof. There are also lots of definitions which make it enable us actually to reveal, disclose some properties which otherwise we couldn't actually find, you know. So as you can see, for example, on page 56, if we take mu as a fuzzy set in a Hilbert algebra, T belonging to unit interval with level set L different from empty set, then T is called an overlying primable S value for mu if the following assertion is valid, as you can see it. Okay. Then by defining this, then we are able to prove some properties which for T belonging to the closed interval 0.0 and 0.5. Okay, it is there. On page 57, we generalize this to the overlying primable S value for mu. Again, if the level set U is empty, not empty, and the T belonging to the closed interval 0 and 0.5, then we can see that if T is an overlying primable S value for mu, then the strong lower T level set of mu is either empty or a subalgebra subalgebra of H for T belonging to the closed interval, as I mentioned before. On page 58, we have a lemma, which is a very nice lemma actually for a fuzzy set mu belonging to the Hilbert algebra. If T belonging to the unit interval is a primable S value for mu, then the level set is an S energetic subset of H whenever it is non-empty. It is empty, so it is not true. So we have this. So we have this proof. Okay. Then on page 59, if we take any fuzzy set, you know, mu belonging to H, and if we assume that the level set, both level sets mu, U and L are different from an empty set, and T belonging to the interval 0.5 open from the right, if T is primable S value for mu, then it is an overlying primable S value for mu. And then this is the proof. On page 60, we have another which we are looking at actually the strong lower T level, not the upper, but lower T level set for mu of a subalgebra of H, and it is shown that the overlying primable S value is a consequence that T is overlying primable S value. Okay, and 61. Again, we get a result when we take care of L, you know, the level set L, which before we defined it, you know. If it is non-empty, then if T is overlying primable S value for mu, then the strong lower T level set of mu is a subalgebra of the Hilbert algebra H. And the proof is easy. Follows from the definition. And this is references, as you can see it, Wozniak and Diego, Dudek, Tuaf'ın Zade, 3 papers. Thank you. Thank you very much.
Thank you,
And
sir.
thank you. Sorry for disturbances and these sort of things. Okay, thanks a lot. I hope that I didn't go over the time, and the time is yes. Thank you very much.
Thank you very much, sir.
The discussion was very technical in the morning here, and I don't know. It is actually there maybe 12:40 or something like that. Yes.
Yes, sir.
Yes.
Yes, sir.
Okay. Thank you.
No, it's you understand, sir. It's useless.
Yeah.
Now we shall have a vote of thanks. You now like to
Invite Dr. A. Muthuselvi, Assistant Professor, PG and Research Department of Mathematics, SFRC, to deliver the vote of thanks.
Honorable guests, esteemed speakers, distinguished participants, on behalf of the organizing committee, it is with immense pleasure that I extend our heartfelt gratitude to each and every one of you for your active participation and valuable contributions to the third session of the international conference titled Mathematical Challenges and Novel Applications. We are deeply honored to have the esteemed Professor J. Jafari, College of Vestsjaelland, South Mathematical and Physical Science Foundation, Denmark. His expertise and insights into the topic on some values and sets in Hilbert's algebras based on fuzzy points provided us with valuable perspective and deepened outstanding of fuzzy concepts. I would also like to express our sincere appreciation to the Department of Mathematics of SFR College, ANJAC College, and Rampo Institute of Technology for their collaborative efforts in organizing this conference. Your unwavering commitment to fostering academic excellence and felicitating knowledge exchange has been instrumental in the success of this event. Thank you once again to everyone who has contributed to the success of the international conference on the mathematical challenges and the novel applications. Thank you.
Thank you.
Thank you very much.
Thank you, sir. Shall we wind up here?
Thank you.
Thank you, sir.
Thank you very much.
Thank you all for your attention this morning. It's now time for our lunch break. Please enjoy the lunch provided